Okay. So the simplest square root function is the square root of x. Can anyone give us the domain of this? Savannah, would yes?
0, positive infinity.
Very good. Okay. So here's the graph. The graph of the square root is like this. A little bit higher here. It's not like this. It's not like this. So it's a little bit not touching several times, but slowly away from the x-axis, from the y-axis. So the square root of x. If I want to graph the square root of x plus 3, what is the domain of this function? What do I have to write, solve, in order to find the domain of this one?
The restriction?
Yes, what do I write? The restriction. What restriction do I have to write?
It will be x greater than or equal to
X plus 3, the quantity under the square root must be
must not equal to 0.
greater than or equal to 0. So this is greater than or equal to -3, so from -3 to infinity. The domain tells me what happens to this function, where it's going. That's why we always should determine the domain before we do anything else. So can anyone tell us where does this graph go?
It goes to the left 3.
Exactly. Very good. Can anyone give us the range of these functions?
Bracket 0, infinity.
Very good. Great job. Okay, so that's all I had to say about that. So let's review exponential functions. Last one. Exponential. Exponential functions are called exponential because the power is the variable. This is the base, which is a number. This, the exponent, called power also, is the variable, the independent variable. These are nice functions. Friendly when it comes to the domain. Anything goes, no problem. But never in my career I thought I would say what I'm going to say to you now. Now we're all scared of it. So if the base is greater than 1, we are all scared of it. And here's why. It has the highest increase possible. Fastest increase possible. And that's why we say maybe we can flatten this curve somehow with this pandemic. But few people get infected and then 3 days later it's 3 times as much or 10 times as much. So this is a scary function. In this day and age, I can say it's a scary function. Because once few people get infected and it spreads so far, increase, the rate of increase is so the fastest possible that we can think of. So that's why they say we want to flatten the curve. We would like this to happen, but at least do this, or not that fast, maybe something like this. So it's a scary thing. I never thought I would say that. Now, if the base is less than 1, between 0 and 1, then the function is the reverse of that. It's like this. So this is still a to the x, but with a base tiny, like, let's say, 1/2 to the x, or 1/16 to the x. We have here with a base greater than 1, we have two functions that are very well known. Common exponential function, which is 10 to the x. And there is one called natural. A lot of natural, from nature, phenomenon follow this. So that's why it's called natural exponential function. They are so famous that they have their own key in the graphing calculator. It's right here. See, 10 to the x, right here. It's activated with the second key, 10 to the x with the second key right here. And here it is, e to the x. If you want to put a power on e, you have to use this. So let me get out of there and clear everything. So if I want second e, the power 4, you may need to put parentheses depending on the type of calculator you have or not for the power, and that's it. Now, if you don't want to put any power on it, I recommend this. It's right here in the division symbol, still activated with the second key. And then you press enter, and then you see what e is all about. 2.71828, blah, blah, blah. Now, if you want 10 to the x, then you go to second and 10 and put power whatever, and you know what that is. Now, also, not today, because it will come up later, but 10 to the x and log are inverses of each other. That's why they share the same key. The log is without the second key, but everything that is in blue on my screen is activated with the blue key. If it's in yellow for your calculator, then it's activated with the yellow key. And this is, of course, e to the x and natural log. They are inverses of each other. They share the same key. Okay, back to what I was saying here. So these follow the same pattern. The higher the base, the closer, the faster the increase, which means this branch, this piece will be closer to the y-axis. So if I want to graph 2 to the x, e to the x, and 10 to the x, 10 to the x will be the closer to the y-axis. E to the x will be the next because it's 2 point, and then 2 to the x will be further away. We can do that real quick if you'd like. So you can see, so we go to y equals, clear everything else you have. We don't need that anymore. So if I graph in order 2 to the x, 2 caret x, then the next one, 10 to the x, and then the next one, e to the x. So look at the colors, blue, red, and black. Red must be the closest to the y-axis, then the black, and then the blue. I will use still zoom standard. 6. Here they come. Blue, red, the closest, and black in between. Okay? The higher the base, the closer, the faster the increase. Okay.
So
Yes? Yes?
on the exam, are we allowed to use our graphing calculator? Or do
Absolutely.
We have to use the one that's provided like on there?
No, absolutely. You are allowed to use a graphing calculator.
Thank you.
Thank you. Okay, so finally, let's talk about the last item here, the supply and demand functions. And that's it. We're done with R. It took me 3 weeks. Wow. A lot. I have a lot to tell you. Sorry. So supply and demand functions. Supply and demand functions. Okay, so let's take a look at a little graph here. Let's say this is price on the x-axis, and here is quantity. So let's think in terms of homes. So let's say we are interested in getting into a business of building homes. So we want to build homes, and we have everything we need. We have the experts. We have everything. So the question is, what do you think it will be more advantageous for us to make and to build a lot of homes at a very small price, or build less homes but at a higher price? Well, the answer is we would love this to happen. So the higher the price, the better for us, because we supply. And we want to higher the price to make more profit. So the supply is always an increasing function. As price increases, we are willing to produce more and more and more to make more money. But what about now we are a customer? Can everyone afford $10 million homes? No, no. So this is what is called the demand function. Why? Because the higher the price, fewer people can afford. The lower the price, more people can afford. This particular point here, it's called the equilibrium point, EP. So EP stands for, oops, equilibrium point, where everyone is happy. We are happy to buy at this price, and they are happy to produce at this price. So this is P, and this is quantity. Everyone is happy. Where these two lines intersect, we're happy with the price, they're happy with their profit. So let's take a look at a problem. Anywhere on page 65. Let me see, maybe I can get to 65 quickly. Of course, it was turned off. Now I guess I have to wait for a second to wake up. Oh, it's awake. Wonderful. Great job, thank you. Oh, of course not. Okay, so let's choose any of these and talk about the equilibrium point. So 91, 92, 93, 94, 89, you choose. The functions are given to us, and we want to determine the equilibrium point.
92.
92, very good. 92 it is. On 65, is it? Yes. Okay, 92, we have the demand. It's denoted by Q. And the supply, also denoted by Q, which is x squared plus 2x and plus 6. They're asking to find the equilibrium point. Oops. Go away, I don't need you anymore. Yes. I was talking to my tablet, not to you, of course. Okay, so how do we determine the equilibrium point where the demand and supply are the same? What do I have to write?
You set them equal to each other.
Thank you very much. Indeed, x minus 4 squared equals x squared plus 2x plus 6. Perfect. Well done. Okay. Shvam, can you square this for us? X minus 4 and give us the expanded form.
Let's see, x minus 4. Let's see, x minus 4.
No, we learned how to expand with no distribution. Just give me the final form. If you don't want to use the formula, it's okay. Just give me the final form.
X squared
Good.
minus 8x
Very good.
and plus 6.
Great job. Good. How do we continue? Savannah, will you help us? How do we continue?
Would we like combine like terms?
Good. What will be the next step? Yep.
So it would be x cubed. Wait, not cubed. Sorry, x to the fourth, and then minus 6x plus 32.
So what are you doing? I'm not sure.
Wait, so we don't combine like terms?
But which terms are we combining?
Oh, I just did the whole thing. You want me to do like one at a time?
But just tell me what are you doing so I understand.
Oh, well, like x squared and x squared on both sides would combine to be x to the fourth.
But when I add an apple to an apple, do I get x to the fourth?
Oh, would you get 2x to the fourth?
So the question is one apple plus one apple.
Huh.
So if I add two.
Oh, 2x squared.
Exactly.
Sorry, I was just not.
That's okay. I just want to make sure. Okay.
Yeah, you're good.
Perfect. But since they have the same sign and they're on opposite sides of the equation, then what happens? They have the same sign.
Don't they cancel out?
Thank you. They do cancel out. So now this becomes linear. What will be the next step after I cancel out the x squared with x squared?
You can subtract 2x.
Of course, I'll subtract 2x. And I have to subtract 16. I move 2x. What do I get? Very good. I move 16. What do I get?
Negative.
Good. And how much is x?
1.
Good. So then the equilibrium point has x equals 1. How do I determine the y coordinate of the equilibrium point? Okay, so how do I do that? How do I get the y coordinate? One, they have to be the same. I just started with them being the same. It doesn't matter where I go back to. So if I go back here, what do I get for the y?
9.
Very good. This is the equilibrium point for the given demand and supply functions. Great job.